Hello everyone, my name is Mouhamed Zakiou Kolawole Adissa, Raimi. I'm a PhD candidate biosciences from Benin Republic, and I have a great honor today to present you my work, honey and black seed synergistically promote regeneration of oligodendrocyte in cuprizone intoxicated coil brain. So here is my outline. In the central nervous system, we have two types of cells, glial cells and neurons. Glial cells are mainly astrocytes, oligodendrocyte, and microglia. They support neuron. Type of oligodendrocyte are myelinating oligodendrocyte and satellite oligodendrocyte. Oligodendrocytes regulate the speed of the action potential transmission, assist the neuron in the axonal transport, maintain their integrity, provide them nutriment and iron. They are highly populated in the corpus callosum, in the subventricular zone, and in the cerebellum. They may be damaged by injury, by toxin exposure, by inflammation, by degeneration. The disorder are dysmyelination, that's leukodystrophy, and this demyelination, that's multiple sclerosis. Multiple sclerosis is an autoimmune disabling disease of the central nervous system and affects 2.8 million people worldwide, mostly young adult people. And the symptoms can be diverse in the human body. In the central nervous system, we can observe like fatigue, cognition, impairment, depression, unstable mood. In the visual, in the speech, in the throat, in the musculoskeletal, in the sensation, in the bowel, and in the urinary. Treatment approaches are so far medication that only help to relieve the symptom. We have stem cell therapy that is very also very expensive, and the choice of a stem cell is very challenging. We have hormonal therapy that also have side effect. And we have natural product that does not have side effect. They are low of cost and they can respond after long term of use. So for this disease, we need a natural product that have anti-inflammatory and antioxidant effect. That's why here we use honey and black seed. Multiple sclerosis model are so far experimental autoimmune encephalomyelitis, toxin-induced demyelinating model, and people use mostly cuprizone. And here we try, and all of these models are being used in the mice. So here we try to develop a new animal model for our study. Our new animal model here is Japanese coil. And this animal model has been chosen because it have a large number of offspring in the few time, and the next generation can come after 16 to 17 days. So we aim to estimate the oligodendrocyte population in the demyelinated and remyelinated animal brain to compare the effect of honey and black seed and the mixture of the honey and black seed in the cuprizone-treated coil brain to find out the most effective treatment to confirm the amelioration in the behavior of animal remyelinated by honey and black seed. So here is our methodology. We use coil male at 14 weeks old. We use 35 animals that we split in in 7 group of 5 animal per group, and we mix 200 milligram of cuprizone with wheat flour to make small ballon that we administered to all of our group for 6 months. Then after 6 months, we then sacrifice the animal of positive control group and negative control group of 6 months. to appreciate, to assess the effect of the cuprizone in the damage of oligodendrocyte. And after that, we kept one group without any treatment of honey and black seed for 6 weeks to assess the spontaneous remyelination. And then we administered honey at 100 milligram, black seed oil at 100 milligram, and the mixture at 200 milligram for respectively 3 of the remaining group. So here is our result. Here is the full brain of the coil, and here is the half brain of the coil. Here we have cerebrum, here we have cerebellum, the midbrain. So as our animal model doesn't have a clear defined corpus callosum, we focus our work in the cerebellum. So after 6 months, we did histology of normal brain and the cuprizone treated brain, and we observed that the thickness of the white matter in the cerebellum fold is decreased in the cuprizone treated brain compared to normal brain. So we also observe that in the white matter of the cerebrum, oligodendrocyte have with branches, and we observe dead oligodendrocyte in the cuprizone treated brain. Same was also observed in the cerebellum white matter of normal brain, and also in the cerebellum of white matter of cerebellum of the cuprizone treated brain. Likewise, we also perform body weight that show us at the end of the treatment, we observe 5% body weight loss after 6 months of treatment, and people observe 10% body weight loss using rodent, using also the same dose of cuprizone, and also for 5 weeks. So we thought that the difference may be due to the double number of neurons in the bird than mammal of the same brain size, or maybe due to the dose of the cuprizone we use. We also observed that the body weight has likely been increased in the treated group of honey and black seed in the mixture. So at the end of our experiment, we then sacrificed the animal of the remaining 5 group, and we did histology using hematoxylin eosin and count the number of oligodendrocyte population in the white matter using image J. So we noticed that the population of oligodendrocyte has started increasing in the group left for spontaneous remyelination assessment. Also, honey and black seed group and the mixture also show more oligodendrocyte compared to cuprizone treated group. So here is our result. When we compare the group left for spontaneous remyelination assessment to the group of cuprizone treatment of 6 months, we compare that the population is higher here compared to this group. So meaning that the spontaneous remyelination has occurred. And again, all the group treated by honey and black seed and the mixture also have high population of oligodendrocyte compared to cuprizone treated group. These results are similar to what people has found assessing remyelination in EAE model in Pakistan animal model using mouse. We also did behavior study, and we observe for that we use beam walk test and flight test. So for beam walk test, we score our bar to 0.20, and we left the animal cross the bar and record where they sleep. For flight test, we left the animal fly at constant high, and we record the length of the flight. So our results show that all the animals treated by honey and black seed and the mixture have higher score either for beam walk test or flight test compared to group treated by cuprizone only. So in conclusion, cuprizone induced oligodendrocyte death after 6 months of treatment. The spontaneous remyelination has occurred after the arrest of the treatment, and honey and black seed improve the oligodendrocyte population regeneration, and even the animal behavior also was restored. But the mixture was more efficient. So in the future, we plan to use a specific antibody to assess all the glial cells involved in multiple sclerosis using same animal model. Thank you for your attention.